Last time we set our sights on the analgesic holy grail, NaV 1.7, and named the hardest hurdle it faces, selectivity, because it has 8 nearly identical siblings. Today we meet all 9 members of the sodium channel family at once. They share one bloodline, yet each holds its own post. Some run the heartbeat, some carry searing pain, some drive muscle, some ignite the brain. Only by telling them apart can you know which one a drug should hit and which it must avoid. First, the family portrait. From NaV 1.1 to NaV 1.9, all 9 are voltage-gated sodium channels, and all do the same job: ignition, driving the steepest upstroke of the action potential and setting the signal off. But they station at different posts across the body, falling roughly into 3 districts. One runs the brain and central nervous system, one runs the heart and skeletal muscle, and one deals purely with peripheral pain. District 1, the brain. NaV 1.1, NaV 1.2, NaV 1.3, and NaV 1.6 mostly guard the central nervous system, letting neurons fire properly. When they go wrong, the consequences are grave. A loss of function in NaV 1.1 causes Dravet syndrome, an intractable infant epilepsy. So if a drug accidentally blocks this district, at best it brings numbness, at worst seizures. District 2, heart and muscle, the 2 high-voltage lines a painkiller must steer clear of. NaV 1.5, which we covered in episode 3, runs the heart's ignition. Block it by mistake and you get arrhythmia, long QT type 3. And NaV 1.4, stationed in skeletal muscle, drives contraction. Block it and a person suddenly loses strength, even periodic paralysis. These 2 must not be touched. District 3 is the real star: peripheral pain. NaV 1.7, NaV 1.8, and NaV 1.9, these 3 siblings cluster on the pain-sensing neurons of the dorsal root ganglia, the iron triangle of pain transmission. NaV 1.7 amplifies the faint signal, as we covered last time. NaV 1.8 carries the bulk of the action potential and is notably resistant to tetrodotoxin. NaV 1.9 lowers the threshold and sustains that slow, lingering ache. Now the selectivity battlefield is clear. An ideal painkiller must precisely block the pain trio, NaV 1.7, 1, 8, and 1, 9, while never touching the heart's 1, 5, muscles 1, 4, or the brain's channels. The 9 look so alike that a hair's difference can lead a mile astray. And in recent years, precisely because NaV 1.8 is more pain-specific and further from the heart, humanity claimed a corner of the grail there first. In 2025, a NaV 1.8 blocker called suzetrigine was approved, the first non-opioid painkiller with a brand new mechanism in decades. So how do you tell these 9 near-identical siblings apart and figure out which a drug hits and which it spares? Again, with patch clamp. You test the candidate against each of the 9 subtypes, one by one, and draw its unique selectivity fingerprint, revealing whether it's a cure or a hazard. This is required study not only for painkillers, but for every anti-epileptic, anti-arrhythmic, and local anesthetic. The 9 siblings now all known. Next time, we go inside the hottest rising star of the pain triangle, NaV 1.8, and why it was the first to claim a corner of the grail. Follow Channel Observatory, and we'll take them one channel at a time.